afternoon. My name is NAJWA SALIM and I want to introduce you guys about related rates and cylinder. Related rates problems involve two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. So what is the importance of related rates? Related rates are important because often one variable's rate over time will impact another variable's rate over time. If one rate known, it can be determined how the other variables is changing using calculus. Related rates are seen all the time in everyday life. Related rates problems often involve geometry shapes such as cylinder because they provide a straightforward way to illustrate how different variables such as height, volume, and surface area that change with respect to time. For example, as you can see, these glasses, if a glass is being filled with water at a constant rate, someone may want to know how quickly the volume of the water inside the glass is changing.
My name is BATRISYIA BINTI HERWAN and I will explain to you the problem statement that we need to solve. A cylindrical glass has a height 4 times its radius is being filled with water with a rate of 20 cm³ per second. A. Show that the volume of water is given by volume is equal to 1/16 times pi times height cubic. B. How fast is the height is increasing at an instant when the height of water is 8 cm. So, the first one, we need to find important information from this equation. We know that R is the radius of the cylindrical glass. It is stated that the height of cylinder glass is 4 times of its radius. It means that the height is equal to 4R. It is given that the rate is equal to 20 cm³ per second. cm³ is referred to volume, which means dV, while second is referred to time, which is dt.
Okay, before that, how I get dt is equal to plus 20? Why not negative? This is because the equation states that the cylinder glass filled with water. So that means the volume of the cylinder glass is increased. Okay, we back to the question A. We need to prove that and we need to get the volume of the cylinder is this equation. First, we need to determine the actual volume of cylinder glass. This is the actual or the first volume of cylinder glass. First, we need to find what is the value of R squared. Okay, we can get the value of radius by the height that we just calculated from this. Okay, height of the volume is 4 times R. We need to single this R. So just leave the R alone and bring 4 beside. So we get the value of radius is h/4. And then we need to substitute this value of R into this equation of the volume. Okay, first, volume is equal to pi bracket h/4 that we just search it just now, h/4, we just substitute bracket square times h. And then we need to expand the value of h/4. H times h, we get h squared. 4 times 4, we got 16 and times h. And then we need to touch it and separate the 1/16 from pi times h cubed until the volume is same. Back to the question B, how fast is the rate? So we want to find what is the dH dt of the cylinder glass. Okay. dH dt, we can find this by build the equation. dH over dt is equal to first dH over, and then we need to times first. Times over and then over dt. Okay, now the value that already exists is dV dt. So we need to substitute this dV dt into this equation. dV dt. Now when this dV and this also will dV. Okay, so now we want to find dH dt. We want to find this by what? By differentiate the volume of the cylinder. Okay, I will show the step of differentiate the volume of cylinder plus. Okay, first is we need to write dV over dH equal to bring 3 in front, and it will get like this: 3 bracket 1 over 16 bracket times 5 times H 3 minus 1. We need to minus 1, and then we get 3 dVdH is equal to 3 over 16 times 5 times H squared. But this equation is dVdH, but we need to find dH/dV. Pictures 38. Okay, for example, this 3 over 16 times 5 times H squared, we need to change it into like this. We need to put over 3 over 16 5 H squared. So we just need to change its position, dH to dH over dV, and we get. Okay, for the first step is we need to find what is the value of dH/dV. From the equation class, we just know that dH over dt is equal to dH over dV plus dV over dt. dH over dV that we just calculated just now, and we get the value of 1 over 3 over 16 times 5 times H squared. And this 20, there's the value of dV dt. 20 times 1, we got 20 over here. We write this to be equation given to this 3 over 16 times 5 times H squared. And then we need to make sure that, we need to change the position to make sure that this equation is in the state of times. So we need to change the position, we need to stack along this 20. So 20 divided by 3 over 16 times 5 times H squared. Then we just change the position of this. We need to then get 20 times 16 over 3 times 5 times H squared.
My name is NAJWA and I will continue the last step. For the last step, we need to substitute the value of H into the dH over dt equation, and it will be 320 over 3 pi times 64. After simplify, the final answer is 5 over 3 pi centimeter per second. For conclusion, we can conclude that the application of differentiation is used to compute the rate of change. We can accurately count the difference in change happen. The differentiation also include the relative of constant, polynomials, several variables, hyperbolics, speed, exponential, and other more. We must understand what is related rates and know that it can be used in our daily lives. Thank you.